Okay, so today we're going to learn about friction. Do you know about friction?
No.
Okay, so there's two types of friction. There's kinetic friction and there's static friction. Kinetic friction is a resistant force. It generates heat or sound, like when you rub your hands together. And then static friction is a resistant force as well. Like its strength can change, like when you're like moving a heavy object. This even applies with Newton's laws of motion. Like the first law is an object in motion will stay in motion. Like when a car is moving, it's in motion. And an object at rest will stay at rest unless an unbalanced force acts on it. So right now, when I just set it down, it's at rest. The second law is an object that has an unbalanced force acting on it will accelerate in the direction of that force. So when we push it down the ramp, it's going to go down that ramp. And then the third one is forces always occur in equal and opposite pairs. So like the forces are going to go
Opposite.
yeah. Okay, so an object's forward motion will continue until an unbalanced force acts in the opposite direction to stop it. So, like if I put the book right here, like the car will continue going until like it hits the unbalanced force, but we're not gonna put anything there to stop the car. Friction, like the definition, is resistance on any two objects in contact acts on the opposite direction of the motion. Friction works against the direction of the movement. It always slows the object down or stops it. The amount of friction depends on the material. The rougher the material, the greater the friction, which means the slower it will go. Speed, it tells you how fast you're going. So, like when it's speeding down the ramp, like that's, like it will tell us how fast it's going. And that, like we can measure in units of distance per unit of time. Acceleration is the rate at which motion changes. And to find that, we could do mass times like the gravity, and then like the height of the ramp, and then like the velocity. So we do mass times the acceleration plus the Fx equals mass and acceleration, and gravity always equals 9.8. And the angle of the ramp plays part in the acceleration. The steeper the ramp, the faster you will speed up. So like if it was like higher, the angle, like the car will go faster. Force, a push or a pull involves two or more objects. So like the car, it couldn't like just go by itself. Like there needs to be like a push, like giving it so that it could like go. There are three main forces accounting for movements: friction, resistance that the surface puts on anything sliding over it, drag, friction of air molecules, acceleration, any change in velocity, speed ups or slowdowns in turns. And the uses of friction is rubbing your hands together like that, pressing the brakes on a bicycle, which causes the bicycle to slow down due to the friction of the brake pads, and car tires, which is the treads, to increase the friction so the car doesn't skid. So we're gonna try like having the car slide down on the ramp and see like which friction will like make it go faster. So we're gonna try just like the car on the plain side. So what do you think will happen when we slide the car down, just like that?
It'll probably just go straight down.
Do you want to try?
Let's see what happens. Oh, geez, it went far. That is good. That went far this time.
So it went about 56 inches.
56 inches.
Yeah.
That one could have been the first time.
What do you think will happen when we use this kind of material to slide the car down?
It might go a little slower. Oh, we shall see. Okay. Here we go. Let's slow it down a little bit.
It went about 38 inches. Do you know why it slowed it down?
Probably because of the material.
Yeah, because the friction with it slowed it down. Friction always slows the object down. So let's try the sandpaper with it to see how it reacts.
Should we put it up here a little more? Because where it starts, because I don't know if it'll hit the. Oh, it didn't stick.
It's okay.
Well, it went pretty far with the sandpaper.
It went to about 34 inches.
Because of the grip from the paper.
Let's try the cotton with it to see.
Okay.
What do you think will happen with it?
It might probably stop it or slow it down a little bit, but we can try it. It didn't go nowhere.
Why do you think it didn't go anywhere?
Because of the friction?
The friction, it always slows down or stops it. The rougher the material, the greater the friction. So this material, it was like rough. So it slowed down the car, like it didn't even like go. So let's try it, let's try wetting it. See what happens. So let's try it, let's try wetting it. See what happens when the ramp is wet. And the water could act like rain.
Okay.
What do you think will happen?
I don't know. Maybe it'll slide. I don't know. Let's try it again. This will be a rough. It like kind of slid.
Do you know why?
Because of the wet? Because it was wet?
No, that far, like it went 31 inches.
because of the friction of the wetness.
It wasn't like rough material,
Yeah.
but
To try that. But we're going to try the dirt next, aren't we?
no, we don't want to.
Okay.
But to find the acceleration of the car, we could use this equation. Max equals mag or mg sin O minus mu k fn, and then we'll just like plug in the gravity, and then like find the equation, like the acceleration of the car, like how far, what the acceleration was. But we'll have to like find we'd have to know the angle of the ramp in order to do that. So that's a good equation. That's just like a reference, just so if you want to ever like find the acceleration of how fast they go down
Okay.
the ramps.
Okay.
So we're gonna find the acceleration of the car, or what the acceleration would be. We have the formula right here on the board. From the formula, I have to get the measurement of the angle of the ramp. So I'm going to take the protractor and find the measurement of the angle. The angle of the ramp is 20 degrees. So we're going to write 20 degrees for that. When finding it, we have to remember that 9.8 is the gravity, so we're going to use that in our equation. So we're going to plug in 9.8 as our thing. We're going to put 9.8 and the sin cos of 20, because that's the measurement of the ramp. That's the angle of the ramp, minus the friction, which would be 0.20, times the gravity, which would be 9.8 again, and the COS, and then 20 at the end. So we're going to take this whole equation right here and plug it into the calculator. So we're going to take that and put 9.8 and then sin 20 minus 0.20 times 9.8, and then the coefficient, which is this, or the COS, and then 20, and that will equal 16. So the acceleration of the car would be 16.